one of the first patented automatic sprinklers came into the market, and it was designed by a gentleman named Henry Parmalee. He actually had a piano manufacturing company, and to save money on his insurance premiums, he came up with a sprinkler that looked like a salt shaker. It was just a perforated cap that he stuck a solid brass cap over and soldered it to the frame. When that solder reached about 155 degrees, it would melt, and the water pressure underneath would pop the cap off and give you this right here. That is an actual Parmalee sprinkler from 1874. Wood frame construction was typical, so the idea was to get water onto the structure and then onto the fuels below. In 1878, the demand for this sprinkler was so much that Parmalee couldn't keep up with it. That's when he asked Frederick Grinnell, the founder of our company, who had his Providence Steam and Gas Pipe Company right where we're standing, to help manufacture that Parmalee head. In doing that, Grinnell came up with his own designs, and he's really the guy who we consider the father of the modern day sprinkler. Instead of pushing the water through a perforated cap, he's the one that came up with the deflector, with the slots and tines in it that now generate the spray patterns. So up until about the 1950s, you had the old style or conventional style sprinkler. About 40% of the water going up and the rest down. These are no longer sold in the U.S. unless you might see them underneath maybe a pier, a wooden pier, or some place that requires underneath protection to get water up and down. But these aren't typically sold in the U.S. anymore. But that's your conventional or old style. In the 1950s, with different building materials becoming less combustible and more fire testing, it was actually proven that putting the water in the downward direction achieved better fire control than pushing water up and down. That's when the standard spray sprinkler came into the market. So I'm going to show you here a standard spray upright, which has a nice umbrella-shaped pattern and a very uniform droplet distribution within its coverage area. If I were to spray a standard spray pendant, it would be the same exact shape, just different orientation of the sprinkler. So that's all training. Everything you see wrong is to see if you're really good at what you do. So you're right. The frame arm should be parallel to the pipe, but they're not. Now, the idea of orientation, a lot of people think it doesn't matter. What I'm going to show you right now is that same sprinkler, the upright, installed in a pendant position. We're getting good density under the head, but not good coverage area. Orientation makes a big difference. That's an upright head installed in pendant position. Everything you've seen so far is 5.6, 5.6. We also have standard spray. So when you think of categories of sprinklers, you have spray sprinklers. They're either standard spray or extended coverage, right? So now we have a standard spray sidewall, installed a lot lower from the ceiling than it should be, but it's more to show distribution. So now when you hear standard spray, standard coverage, that deflector is designed so that if the flow rate from that heading goes up, the coverage area stays the same. It might flex a little bit, but what's going up is the amount of water within the coverage area. The standard spray, standard coverage heads are the most widely used sprinklers in the industry because just by upping the flow rate from them, I can use them to protect a light, ordinary, extra hazard space. But you got to remember, density goes up as flow rate goes up, not coverage area. But we also have extended coverage spray sprinklers. And those deflectors are designed to allow the coverage area to expand when the pressure at the head goes up. What doesn't change, though, is the density hitting the floor. That's why the data sheets have to tell you what hazard an extended coverage head is listed to protect. So here's an extended coverage sidewall. So you can see right now, nothing's hitting the concrete. So if I increase the pressure, right, so I gotta go, if I put the pressure on too high, we'll get wet. So as I increase the pressure, you're going to see the pattern expand. The water is now starting to hit the concrete over here. And you know the benefits of extended coverage. I can cover more area with less edge. Less branch line, less labor. I'm getting wet.
How well do mist make work?
Water mist?
Mist eggs, you know, like they have eggs mist.
Yeah, so
How well do those work? Because they say if you take the oxygen out of the room so it can control fire better and that.
yeah,
I don't know how you feel about that.
water mist, you have two scenarios that you use it. One's called total flooding, where you have a buttoned up room, and the goal there is to extinguish a fire. You then can use water mist to control fires for light and ordinary hazard spaces. And water mist is very effective when the fire is bigger than smaller. Meaning, the bigger the fire, the better chance you have to convert those small droplets to steam, which displaces oxygen and helps control the fire. Otherwise, it takes a real long time for water mist to control a fire when it's small. It has very good applications, but we need a lot more study to do to determine whether it's equivalent to sprinkler systems. There's a big fight right now in the industry to put it in 13 to say that water mist is equivalent to your traditional sprinkler system, but we're just not there yet to confirm that statement. There are some very good applications for it, but it's a case-by-case scenario. This is with water mist, you need pressure. So you're talking about a lot of pump pressure. You have K factors of like 0.24. So you're trying to push a lot of water out of a small orifice. All right, residential sprinklers. Everything I've shown you right now has been commercial. For a commercial sprinkler system to be considered successful, you know how you have to design them for a certain footprint of the building, 1,500 square feet, 2,000, whatever that may be. If the system controls the fire and traps that fire within that area, that's a successful system. Someone might die, that's just very unfortunate, but it's more for property protection than anything else. Residential sprinklers are for life safety. So their design and all the tests we have to pass have to prove that we can keep the space that fire started in. We have to keep those conditions tenable for at least 10 minutes to give someone, even in the room of fire origin, time to get out. These have a very different spray pattern than your typical standard spray. The pattern's been lifted to get you high roll wetting, right? So typically your combustibles in a residential space are against the wall. You get your drapes, your armoires, whatever. Typically your furniture, unless your house is huge, right? But that high wall wetting does two things. It wets the combustibles around the room, but it also gets water into that hot gas layer to prevent flashover from occurring. The flashover is when basically everything in the room ignites at the same time, right? The conditions are just right. And so by getting water into that hot gas layer, you're preventing flashover from occurring. The reason flashover is more, occurs more in residential spaces is because typically your rooms are smaller in volume than compared to your big spaces in commercial areas. So the chances of trapping more heat is greater when you have smaller rooms. So residential sprinklers, life safety, and prevent flashover. That's their main purpose. Okay. You can see that's a lot different than your standard spray umbrella shape pattern, which is more defined. If I were to increase the pressure of that residential head, they're basically extended coverage heads. That pattern would get wider and higher. But I don't want to get everyone wet, so I got to keep it at this pressure.
What pressure are you running at right now?
12 psi.
Just 12 psi?
12 psi.
Wow.
At the head, you're probably seeing 10. So up to this point, you've seen at most maybe 18 gallons a minute coming out of one sprinkler. But when you get into high pile storage, which I was just showing you over there are times that you have to deliver well over 100 gallons a minute per sprinkler. So, turn this on. So give me a second for this pump to get up there. I'm going to show you now our EC25, extended coverage, K factor of 25.2. It's an upright style sprinkler that is for control mode. It's a controlled mode sprinkler. Out of this one head, we're going to be getting 150 gallons a minute. Much bigger droplets, and you still have that spray pattern, that nice umbrella shaped pattern. We also have ESFR sprinklers. So in the lab, if you go for control, that's different than when you go for suppression. So ESFR sprinklers are another category, suppression mode sprinklers. And so to pass that test, you actually have to reverse the vertical propagation of the fire. You got to start knocking it down. So you have control, suppression, and extinguishment. Sprinklers are not designed to extinguish fires. If you get extinguishment, that's a bonus. But that's not what they're designed to do. Suppression mode, so ESFR, you're going to see two distinct patterns, an inner cone and an outer cone. That inner cone has a real fast downward thrust of water. And of course that outer cone is going to be pre-wetting everything around that fire. So depending on where that fire is in relation to the head, if it's right underneath it, you're going to push that fire down real quickly. So here's the ESFR 25. Again, 150 gallons a minute coming out of this head. For everything I've shown you up to this point, you have the ability to go into NFPA 13 and understand how to space them with respect to each other, walls, obstructions. What I'm going to show you now are special application sprinklers. This is where manufacturers try to outdo one another by making a sprinkler for a very specific use. First one is the back-to-back sprinkler, back-to-back attic sprinkler. So if you think of attics, typically they're triangular in geometry. So if a fire were to start down at the eave, all that heat goes right up the slope and collects at the peak. So the best place to put a sprinkler in an attic of that shape is typically at the peak. Sprinklers are essentially heat detectors. They just happen to spit water when they activate, right? So by modifying the deflector we're able to change the spray pattern of our sprinklers. So when you look at the back-to-back, this is a BB3, which has a very defined angle to its pattern. But you can see here that you install this at the peak, and it'll spray right down to the eaves. What it doesn't have is a very deep, you can see, right? Very wide pattern, but not very deep. So you got to put it every 6 feet along the ridge line to get the right protection. No, you got to know, your joist. You got to follow the line of the joist, right? You can't. Yeah, you got to go parallel. Our data sheet will tell you your joists have to line up. They can't be offset. There's a lot of rules that go into how to utilize. That's a back-to-back. We have a single directional, so you only have to go in one direction. We have a hip sprinkler that goes down the hip line of the roof, and an attic plus that supplements those other three I just mentioned in areas you can't reach with the other three. So they call it the peak performance line of heads.
No?
For instance, if you had an attic space that had an eave-to-eave span of 60 feet, and let's say a pitch of 4 and 12, if you use standard spray, standard coverage heads, you need at least 5 branch lines to do that. Depending on the obstructions in that space, let's say it was a nice wide open space, you could get the same protection with one row of back-to-back sprinklers at the peak with the BB1s. So less pipe, less time, less labor. You typically have a benefit in the amount of water you need for demand, especially for dry pipe systems, versus wet. Wet can be comparable to your standard spray. But a lot of benefits to utilizing the peak performance lineup of sprinklers for attic spaces. All right, combustible concealed. Fire testing showed that for combustible concealed spaces, when the wood above at the top of the space ignited, a lot of times that fire would just go right over the head and keep on going. So we realized that the sprinkler, to be most effective, had to spray water up and down. So the combustible concealed sprinkler sprays water up to get that surface above it wet, but we also lifted that pattern because in tight spaces, the more you lift the pattern, the more coverage you can get versus that umbrella-shaped pattern of the standard spray head. So that is a CC1 head right there. That can protect up to 3 feet. The CC3 can go up to 5 feet of a combustible concealed spray. A lot of the benefits of using a listed combustible concealed sprinkler is that typically the AHJ, if they allow it, well, you can use CPVC pipe in that space, which is just easier to work with than steel. We're going to show you the window sprinkler last because we have to shut the doors. So now I'm going to show you some of our spray nozzles. Right? These are different than the sprinklers. Typically, this technology is used in industrial applications. So these are directional spray nozzles, and we have 2 different types, medium velocity and high velocity. You're trying to achieve one of 4 things with these. You're trying to either put the fire out, control it, don't let it get too big, prevent a fire from even happening, or what's called exposure protection. Fire prevention is, let's say you had tanks out with flammable or combustible liquids. To prevent a fire from happening, you'd have some sort of gas or vapor detection out there. And when that activates, it would trip your system. Typically, they're on a deluge system. And the water would wash away any fuel that might be leaking from one of those tanks to an off-site area to a containment spot. So you're preventing a fire from happening. They're also used for exposure protection, where if you had those same tanks, the last thing you want are those fuels inside that tank to reach their boiling point, because that's when you're going to get deflagration or explosion. So exposure protection is where these nozzles are aimed at the surface, and at the surface of the tank. and you're really not fighting the fire. You're just putting an envelope of water on the tank to keep the contents cool so that the heat doesn't penetrate into the tank. And that's exposure protection. So typically you see that leading to these heads are swing joints, because every year you got to do a trip test and you got to make sure that that water's going where it needs to go. A lot of times they might get bumped, and that swing joint just allows you to modify it, move that head where it needs to go. And so what I'm going to show you now are the D3 medium velocity spray nozzles, typically used for fire control, exposure protection, or fire prevention. They come in 8 different spray angles, 7 different K factors. If they're spraying directly down, that's a 0 degree orientation. They go from there all the way up to 180 degrees, which is straight up, which is shown over here on this guy, spraying against that ceiling over here, you can't see it. We also have high velocity spray nozzles. Typically high velocity is used for extinguishment. You can use it for the other three purposes, but typically you're trying to put the fire out with this. So think of a transformer where mineral oil is your hazard. You're going to inject water at a high velocity into that mineral oil and try to extinguish that fire. Gas refueling stations. Think of a refinery filling up trucks going out for delivery. You're going to have these nozzles around that operation to try to quickly put that fire out. It's going to look very similar to what you've just seen, but believe it or not, you got a little bit bigger droplet coming out at a greater velocity. Those are your high velocity emulsifier series directional spray nozzles. All right, any questions while we get set up for the window sprinkler? All right. I was telling you before, architects, I really like to use glass in the interior of their buildings to let light through and give that nice open feel to the space. The building codes though, they tell you that if you're using one part of the building for one purpose and is adjacent to another, sometimes you have to separate those two areas with a fire-rated assembly. Typically you're going to use gypboard construction, or you can use masonry. But if you're going to use glass, you got a couple options. You can use fire-rated glass, very expensive. The glass just in those two fire demonstration cells behind you cost over $30,000 to get 90-minute fire-rated glass. So you're not going to separate an atrium from the rest of your building with that kind of material. It's just not economical. You can also use the glass that has the wires in it that's fire-rated, but architects just don't like the way that looks. Next option is to use sprinklers. But the standards tell you that if you use a sprinkler, you have to prove that it can wet every square inch of the pane of glass it's protecting. Currently, this is the only sprinkler on the market that does that. So if you were going to utilize anything else, a standard spray sprinkler, technically, you would have to set up the assembly that you're going to protect, run the test, generate a report, and submit that to the AHJ. This, if you fall within the guidelines of how it was tested, 13-foot ceilings, 1/4 inch thick tempered or heat strengthened glass, can't be operable. Can't be using it on a door or a window that can open up. It has to be a stationary piece of glass. That's why architects get pissed off when they do these stair towers or stairways, and when it comes to the door, we tell them that they either have to use a solid core door with smoke gaskets around it, or fire-rated glass, which is real expensive. All right? So keep that in mind. This is very much like exposure protection. We're not fighting that fire. All we're doing is making sure that that glass stays cool so that the heat doesn't cause it to break, which would then allow smoke and heat to get from one spot to the next. So when I turn these on, if you have a hard time seeing it, come to the side and you'll see the sheet of glass going down. But here is your, actually I gotta turn my pump down for a second here. Hold on. So here is your window sprinkler. Now what you're going to see is that the pane of glass that water is spraying on is getting a nice full sheet of water. But the ones adjacent to it are not. And it's because these mullions are acting as an obstruction. So if we were to properly protect this window assembly, we would need one sprinkler per pane of glass. If the glass was butt jointed, I could go 8 feet between each head and get the same level of protection. If there's a horizontal mullion or a pony wall, not a good idea. You would have to somehow put sprinklers underneath that horizontal mullion and provide the ability to keep them from getting wet from the sprinkler above. And to do that, it's really tough to make it look good.
So you said you would need to put a sprinkler head at each pane of glass?
Yes.
Yeah, if we
But
were,
in the code it says not to install sprinkler heads closer than 6 feet.
but these
You know,
mullions,
They're obstructing.
Yeah.
They're obstructing.
these are basically acting as baffles. So, yeah, you're not supposed to go closer than 6.
Yeah.
But the way we tell you is that each pane of glass has to have a sprinkler on it.
It's not flowing through. They said if you had no cross,
But it
like
says,
if it's something that costs, you would have to put another head under it.
But you're talking about minimum spacing.
minimum spacing,
6 feet.
is 6 feet. You can't go closer than 6 feet.
Yeah. But in this situation, if you have to put a head on every pane of glass, that overrides the minimum spacing.
That overrides?
That overrides.
Manufacturer as well, whatever.
So now this is just specifically for glass partitions and windows?
Correct.
And
Lot line windows.
lot line windows. So in a regular lot line window scenario where you have a window and you have a building next to the building you're in that's closer than 30 feet, you need to have that sprinkler. If you don't have fireproof glass and so on and so forth. So now if I sit down and provide that window with a typical head, I'm not in compliance?
Exposure protection is very different. I would not use this option. That's a very expensive option. There are exposure protection nozzles that you can use.
Yeah.
They're much less expensive and provide the protection for lot line requirements. So,
But also the time that you do utilize a lot line head to cover that, you're allowed to also use that head for interior coverage also.
correct.
When you do so you could use a standard typical head.
Sure. Exposure protection for one building to the next is very different than interior walls. When we're talking about interior separation, whether it's a stairway,
Even some interior separations in some places we've had, where you enter the office,
Like a vestibule,
like,
glass vestibule.
we were, where they had all glass, we had sprinkler heads on both sides, inside and out.
standard spray.
He says
Standard
the water
spread heads,
part.
Yeah.
ordinary, typical 5.6 K standard heads.
If the AHJ lets you do it,
Well, that's,
then you're good.
the engineer put on the drawings, that's what he designed, that's what he specified.
We do not support it because if I put a standard spray sprinkler, depending on where you put it,
Yeah,
those top corners of the glass are not getting water on it. It comes down to what's approved and what's not. And so if you're trying to get a fire rated listing, on a window assembly, then it comes down to whoever agrees that what you're doing is gonna provide that hourly rating, or that resistant rating. So somehow that engineer got the AHJ to agree that standard spray sprinklers were gonna do the job.
New York City is gonna have an issue very soon, because it's starting to happen already, that I told you the job, we had to use those hats.
Yeah.
There was no choice because the commissioner got involved, so DOB has hands on right now, and eventually they're gonna make us put
They're
those
gonna make us
every
put
But over the door,
They're
right, the
windows to
door-
the outside and they open.
They open.
actually